Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, welcome back to another video on organic chemistry. We will be continuing with our naming of hydrocarbons or organic compounds, and we will be introducing a couple of more rules to our naming system, and we'll be naming a couple of more compounds. Okay, so let us do that. So far what we've covered is we have learned how to name our aliphatic compounds. Okay, and we've looked at 3 of the aliphatic compounds, which are alkanes, alkenes, and alkynes. Okay, so our aliphatic compounds are alkanes, we've got alkenes, and we've got alkynes. And we know that the difference between alkanes, alkenes, and alkynes are the types of bonds between the adjacent carbon atoms, and we know that this is the following. We know that the following is the difference between the aliphatic compounds. We know that with alkanes we've got single bonds between all adjacent carbon atoms. We know that with alkenes we've got a double covalent bond between adjacent carbon atoms, and we know that with alkynes we've got a triple covalent bond between adjacent carbon atoms, okay, between at least one pair of adjacent carbon atoms. That's basically what we covered, and we learned how to name these different compounds using these rules here. This has been covered in my first video. If you missed that video, I highly recommend in this video that you watch that video before you watch this one. Okay, and just to quickly recap, this is the table, and from this table shows us the rules that will apply when we are naming these organic compounds or the aliphatic groups that we've looked at so far. And we know that the column on the left here are the first part of the name of the compounds that we deal with, and the right side of the column here is the second part of the names that we come up with for our aliphatic compounds. And as an example, we know that if we've got a compound that looks like that, we know that if we've got a hydrocarbon that looks like that, I'm going to do this very quickly because I'm just recapping. This has been covered in a previous video, and we want to find the name of this compound. Then all we have to do is look at the types of bonds between all adjacent carbon atoms, and we see that all the bonds here are single bonds. So we know that this is an ane, it's an alkane, so the last part of the name is ane because it's an alkane, because it has a single bond between all adjacent carbon atoms. If you go back to the first sheet here, you'll see that single bond. This is alkanes, so it's an alkane. Therefore, the last part is ane. And the first part, we've got how many carbon atoms? We've got 3 carbon atoms. If you count here, we've got 1, 2, 3 carbon atoms. So we know that we go back to our table there. You should memorize this table. Go back to our table there. There's my 3 there. My 3 corresponds to prop. So therefore, the first part of the name is going to be prop. So then I have propane. I have propane, so the name is propane of this compound here. Okay, and we did a similar thing with our alkenes as well. I'm just going to do a similar thing for alkene very quickly to basically finish this recap. If I've got something like that, this is an alkene. How do I know that it's an alkene? Well, because I've got a double bond, right? I've got a double bond between adjacent carbon atoms, and the rest of my atoms are hydrogens, and we've got 4 bonds around all my carbon atoms. Okay, now how do we name this? Well, the way we name this is we know that it's an alkene because we've got a double bond, so the last part of the name is ene, right? The last part of the name is ene because if we've got a double bond, here's my double bond there, it's an alkene, so the last part is ene. And how many carbons do I have? I've got 1, 2, 3 carbon atoms. So go back to my table. If I go back to my table up here, I see there's my 3. It corresponds to prop. So then there's going to be propene. This is going to be PROP. Okay, so that's going to be propene. Okay, now that's basically what we covered in the previous video. We can do a similar thing with alkynes as well, but I'm not going to do that here because we did that in a previous video. Okay, so now in this video, we will continue with naming different compounds, but in this video, we will focus on two new things that I will introduce, two new concepts that I want to introduce. The two concepts that I want to introduce are, firstly, I want to introduce structural isomers, what we call structural isomers. Okay, we've got structural isomers and we've got functional groups. So, and functional groups. Can alkanes, alkynes, and alkenes also happen to be functional groups, but I want to officially introduce functional groups in this video. Okay, so in this video, we'll be talking about structural isomers and functional groups, and we will continue naming our compounds, but I just want to explain what these are before we actually continue naming our compounds. Okay, so in the previous video, before I actually concluded my previous video, I asked an interesting question. I said, okay, let's say we've got a compound. I'm just going to come up with a different compound here, but the principle will be the same. Okay, so I've got this. Let's say I've got this, right? And I've got a double bond there. And I've got another C there. And I've got H there. And I've got H there. And this needs 4 bonds around it. All my carbon atoms should have 4 bonds around it. 4 bonds around it. Okay, so this will have 1, 2, 3, 4 bonds around it as well. Okay, I posed an interesting question in the last video. I said, okay, so if you've got this organic compound, right? You've got this organic compound and we know how to name this organic compound, and we actually named this organic compound. If we name this organic compound, let's do it very quickly because now we know how to do it. We know how to do it very quickly. Let's quickly name it. Firstly, we know that this organic compound falls under the alkene group, the alkenes group, right? How do we know that it falls under the alkenes group? Because it has a double bond there between adjacent carbon atoms, and we know if we go to the first page there that if we've got a double bond, then it is an alkene. And if it is an alkene, we know that the last part of the name of that compound or the surname is -ene because it's an alkene. Therefore, I know that the last part of this compound is -ene. So I'm just going to say, I'm going to write -ene here, right? This is the last part, the last part of the name of this compound. And what is the first part of the name? I've got 1, 2, 3, 4 carbon atoms. I've got 4 carbon atoms. If I go back up to my table there and I look for 4, here's my 4 there. My 4 is related to the bute. So therefore I know that the name of this compound that I drew out here is the first part of the name is BUT. So then this compound is butene. Okay, easy peasy, that's very easy to follow. We've done a couple of examples in the previous video showing that, and this is very easy. Now, here's an interesting scenario. You will notice that in this compound, in this organic compound, this double bond is there. But there is nothing stopping me from taking this double bond and having it there, or having this double bond there. There's absolutely nothing wrong with me having that. Okay, there's nothing wrong at all with me having my double bond either in the middle or at that location there. Now, if I want to move my double bond, I'm gonna have to be specific as to where my double bond is exactly. So if I give someone the name of this compound, right, and I want my name to illustrate exactly or to explain exactly where my double bond is, I've got to find a way somehow to put that in the name of butene, right? I can't just say butene, because remember what makes butene butene? The thing that makes butene is the double bond and the fact that I've got 1, 2, 3, 4 carbon atoms. So if I draw a different butene, right, I'm going to draw butene still. So I draw butene here. There's one. Then I put my double bond. I put my double bond in the middle there. Then I draw my thing there. Then I draw my thing there. Then I've got 4 bonds around all of my carbon atoms. I've got 4 bonds. So here's my hydrogen there. Here's my hydrogen there. Here's my hydrogen down there. Okay, it's just hydrogens all over, hydrogens all over, hydrogens all over. Okay, so if you look at these two atoms here, right? If you look at the atom at the bottom and the atom at the top, let me split them. Let me draw a division line so that so that they're easy to distinguish. Okay, so you've got this one on top here, and you've got this one at the bottom there. Both of them have a double bond. Here's my double bond there. Here's my double bond there. Both of them have the same number of carbon atoms. Here's my carbon atom there. Here's my number of carbon atoms there. That's 4 of them. And here are my number of carbon atoms there. That's 4 of them as well. Now, these two things have exactly the same formula, right? They have the same exact formula, but they have a different structure. Okay, you can see that all of them have 4 carbon atoms. All of them have a double bond between adjacent carbon atoms, right? So both of them are called butene. Both of them are called butene. This is called butene and this is called butene. But if I were to give, if I were to say to someone, please bring me butene, right? They will ask me, well, which butene do you want me to bring you? Because all of them have a specific structure to them, right? The double bond could be anywhere. It could be here, it could be there, it could be there. Now, which one do you want me to which butene do you want me to bring you? Please put that in the name of the butene. And you can't say butene with a double bond on the last pair of carbon atoms. That is too long. We want a simple way to tell anybody where exactly that double bond is. Okay, now before I actually tell you how exactly to give out that information, there's a term that I want you to get familiar with, and that is structural isomers. Now, if you look at this butene, what do you notice? How many carbon atoms? I've covered this already. How many carbon atoms does it have? It has 1, 2, 3, 4 carbon atoms, right? It has 4 carbon atoms. Therefore, the formula is C4 because it has 4 carbon atoms. And how many hydrogen atoms do they have? Does this have? It has 1, 2, 3, 4, 5, 6, 7, 8. And you could have found this from the general formula, right? You could have found this from the general formula that we covered on our very first video. So now you've got 8 hydrogen atoms. You've got 4 carbon atoms and 8 hydrogen atoms for both of them, right? Here that's 1, 2, 3, 4 as well. And that's 1, 2, 3, 4, 5, 6, 7, 8. Remember, this is butene, and butene is C4H8, right? But these are two different types of butenes. The structure of these two butenes are different. The double bond for the first one is there. The double bond for the second one is there. Okay, so this is the molecular formula. The molecular formula for the butene is C4H8. That doesn't change, right? This is the molecular formula. But the structural formula, the structure of butene is different. The structure of these butenes are different, right? So what do we call this? Well, when you have a compound that has, when you have more than one compound which have the same molecular formula but a different structure, then we call that a structural isomer. That is what structural isomers are. Okay, so a structural isomer is a group of compounds with the same molecular formula but a different structure. You can clearly see that the structure between this first organic compound and the second organic compound are different. Where and how are they different? Well, the double bond here is located there and the double bond here is located there. So this is why we call them structural isomers, because the structure is different. Even though they share the same name, the structure of the compounds is different. And that is what makes a structural isomer. Okay, if I can give you another quick example. Another quick example is if you've got C and then you've got that and then you've got that and you've got this and this, then you've got H here. Okay, and then you've got, remember, 4 bonds around all carbon atoms. 4 bonds around all carbon atoms. Okay, so now you will agree with me based on the example that I just covered right now that this could be anywhere. This could be anywhere. It could be here, could be there, right? It could be in any of those two places, and this chain could be longer so that there are even more possible places where this triple bond could be. You will agree with me that the name of this compound, I'm not going to go through the whole process of coming up with the name. You know how to do that by now, but the name of this is, it's got a triple bond between a pair of adjacent carbon atoms. So you know that the last part is ine, and the first part we've got how many carbon atoms? 1, 2, 3, 4. Therefore, it's butane, right? It's butane. If you use that table, you will see that this is butane. But this butane could have this triple bond anyway. It could have it there, it could have it there. So we need to find a way to include that in the name. We need to find a way to include the fact that the double bond is here and not there, right? Okay, so now how do we actually get to doing that? Well, the way we actually get to doing that is as follows. Okay, so let's start with the first example that we used. The first example that we used is up here, and this is butene, right? This is butene. Okay, so what I'm going to do is I'm going to draw both of them out again. I've got this 1, 2, 3, then I'm going to say 4 like that. Okay, there's 1, 1, 1, 1, and I'm going to have it like that. Then we know that all of these are hydrogen atoms, H, 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 4, all of them, and every carbon, every C must have 4 bonds around it, 4 lines around it. Okay, right? That was the first one. And the second one that I drew up was that, and I said another C, then I put the double bond there, then I put another C there, and then I said, this is what you have. So it's different structures, same molecular formula. This is C4H8 for all of them. Okay, so I've got that, all of these are H's, all of these are H's, all of these are H's, all of these are H's. Just write that a bit clearer there. There's my H there. Okay, so all of these. So we know that both of these are butenes. We know that both of these are butenes. So both of these are butene. Right. Okay, I'm actually going to remove that there. Okay, so cool. Now, how do we establish where a particular bond, a particular double bond is for these two? Where? How do we establish that? Well, what we will do is we will number our chain. Okay, we'll number our chain. Now, where's our chain? Remember in the previous video, I told you that a chain is if you can draw a line, a straight line without breaking, through all your carbon atoms, that forms a chain, right? So before I'm going to come back to this example, but let's say I've got something like this. Say I've got something like this. Then I've got this, and I've got this, and I've got this, and then I draw it, I go down like that, and then whatever. And then I have all my hydrogens bonded to this. Okay, so I have my hydrogens bonded to this. It doesn't matter that this is straight. It doesn't matter that there's a turn there. If I can draw a line through all my C's without breaking the line, or without, a chain is formed by successive carbon atoms which follow each other, right? Which follow each other without me having to break the line. So if there was another, let's say, carbon atom there, if there was a carbon atom that is there, then that carbon atom does not form the chain. It's not part of the chain. Why? Because the line missed it, right? But if this line, for instance, if this line was like that, this is still a chain because the red line goes through all those carbons, and then this carbon does not form part of the chain. Okay, so that's what I mean by a chain, right? That's what I mean by a chain. So going back to the examples, the example that I have there, go back up there, my structural isomer. This is my butene, right? And I know that my chain for this one is there, right? And I know that my chain for this one is there. Now, in order for me to establish exactly where this double bond is along my chain, I have to number my chain, but I number my chain in such a way that the smallest number is closest to my functional group. Now, I just said functional group to you. What is a functional group? Well, a functional group, now is a good time to introduce what a functional group is. A functional group is essentially a group of atoms that give organic compounds their properties. Okay, so a functional group group gives organic compounds their properties. I will explain this in more detail just now. Gives organic compounds their chemical properties, Okay, gives organic compounds their properties. Okay, so a functional group is a group of atoms. You know that if you see that group of atoms, then this compound, this entire compound that I have, will behave in such a way that it indicates that this functional group is a part of that compound. So for instance, the first and simplest functional groups that we've looked at so far are these three. Okay, these are our functional groups. Now, our functional groups in this case, if you have an alkane, right, the functional group of an alkane is a single bond between adjacent carbon atoms. So if you've got a compound and the compound has all single bonds between adjacent carbon atoms, then we know that it's going to behave a certain way. It has certain properties. Same thing, similarly, if we've got a double bond between adjacent carbon atoms, we know that this compound is going to behave like an alkene. Why is it going to behave like an alkene? Because an alkene has double bonds between adjacent carbon atoms. Similarly with this, if a compound has a triple bond between adjacent carbon atoms, we know that this compound is going to behave like an alkyne. So these what you see here are functional groups. Functional groups are groups of atoms that tell us how is this compound going to behave. This tells us that the compound is going to behave like alkanes. This tells us that the compound is going to behave like alkenes, and this tells us that the functional group is going to behave like alkynes. So that's what a functional group is really. It basically gives compounds their properties, and once compounds have those properties based on the functional group, then those properties will behave a certain way, right? That's basically what functional groups are. Now, in this case, when I was doing this example, I say, okay, cool. How do you number these compounds such that you are able to tell where that functional group is or where that bond is? Okay, how are we able to put this in a name, to indicate this through a name, such that when a person reads the name, they know exactly what the structure looks like of these compounds? Well, we do that in the following manner. Okay, so I said you number your chain. You number, this is your chain and that is your chain, right? You number your chain so that the smallest number is closest to the functional group. So you can either number from left to right or from right to left, but you have to make sure that the direction that you choose is the direction that will enable you to have the smallest number be closest to the functional group. Let's demonstrate that. So if I'm going to number my chain here, my carbon atoms, I'm going to say, okay, let me start from left to right. This is 1, this is 2, this is 3, and this is 4. Okay, and then if I go from right to left, this is 1, this is 2, this is 3, and this is 4. Okay, cool. Now, where is my functional group? Here is my functional group here, right? The double bond is my functional group. Now, which number is the smallest that is tied to that double bond? Well, the number that is the smallest, what are the numbers firstly that are tied to that double bond? Well, it's 3, it's 2, it's 4, and it's 1. All of them are surrounding this double bond there. All of them are surrounding that double bond there. So which one is the smallest? Well, the smallest is 1. Therefore, if I know that the name of this compound is butene, right? I know that the name of this compound is butene. But if I were to specify, and if I'm supposed to specify where exactly my double bond is, well, I will do that by simply specifying exactly where the double bond is by using that smallest number. So I'm going to say it's butene, right? This is butene, but instead of writing it as butene, what I'm going to do is I'm going to split the name and the surname. I'm going to split the first part and the second part of this name. So what I'm going to do is I'm going to say this is but, this is the first part of the compound. If you go back to the table, remember, the first part is but, okay? And the second part is what? Is ene. Okay, and but is the name and ene is the surname. So just as you have John Smith or Lerato Vilakazi, the name and the surname are split, right? So I'm going to do the same thing here. I'm going to split the name. So I'm going to say, okay, it's but, that's the first name. But, let me just write that a bit more smaller so that I have more space. Okay, so it's butene. We know that this is called butene, right? So since I know that this is called butene, I'm going to say this is but, B-U-T, and I use the smaller number to identify exactly the smallest number to identify exactly where the double bond is. The double bond is at carbon atom number 1. Okay, then I split it and then I put in the last part of that name there. That's but1ene, and that is the name of this compound. So it's still butene. I've just split the name and the surname. Okay, with the number that has, with the number of the carbon atom that has the double bond next to it. Okay, so that's how you name this atom. So how do you do that with this one, the second one here at the bottom? Well, you do the same thing. You number from left to right and right to left, right? And the smallest number closest to the bond is the number that you're going to use for your compound naming, right? So this is 1, 2, 3, 4. Okay, and this is 1, 2, 3, 4. You number your carbon atoms. Where is your double bond? Here's your double bond there. Okay, and which number is closest? Which number is closest to your double bond and happens to be the smallest number in your numbering system? Well, it's 2. You've got 2 there and you've got 2 there, so that's fine. Doesn't matter which direction you go from. The smallest number is 2, right? Because this number is 3 and that number is 3, and 3 is bigger than 2, so you can't use 3. You must use 2. So the name of this compound is it's still butene, but you split the name and the surname with but, and then you say 2 to represent the second carbon, okay, and then you say ene, 2-butene, like that, okay, and that is the name of your compounds. And you can see now clearly these two names are different, so you can clearly identify what each structure looks like through that number in the middle there. Okay, you know exactly where your double bond is. Okay, and that's it. That's easy. That is how you name this compound using your functional group. These two compounds are called structural isomers because they have the same molecular formula, but their structures look different. Okay, so that's how you go about naming this, using this procedure or this process. Let's do it again. So, okay, so now we know what structural isomers are and we know what functional groups are. Okay, so now let's do a bunch of examples so that we can understand this a bit better. Let's say right now you've got the following. Okay, you've got 1, 2, 3. Let's say you've got that. Okay, I'm just making things complicated here. Okay, not even complicated. I'm just okay. So there's that. Actually, what I want to do is remove that, make that double, remove that, put an H everywhere, Remember, all your carbon atoms must have 4 bonds around them. Okay, what is this? How do you name this compound? Well, let's quickly do that. We follow the very same procedure that we followed in our first video, okay? So remember, first step, what is our surname? Or you could start with the name if you want to, but what is the surname of this compound? Well, this compound is under which functional group? The functional group of this compound is the alkenes. How do I know that it's alkenes? Because I see a double bond there. Since I see a double bond, if I go to my first page, I see that my alkenes have double bonds. So this is my alkene. So if this is an alkene, what is the surname of this compound? It's ene, right? It's ene. Since the surname is ene, I'm going to come back down here and I'm going to say, okay, the last part of this compound is ene. What is the first part of this compound? Well, how many carbon atoms does it have? It has 1, 2, 3, 4, 5, 6. And remember, it must be a chain. It must form a chain. How do we know that something forms a chain? If I can draw a line through all my carbon atoms without breaking the line, without lifting my pen while I'm drawing the line. Okay, the line has to be continuous throughout. So that is my chain. So how many carbon atoms are in my chain? Well, I've got 1, 2, 3, 4, 5, 6. I've got 6 of them. I've got 6 carbon atoms in my chain. Since I've got 6 carbon atoms in my chain, if I go back to my table there, where's my 6? Here's my 6. What is the first name of my chain with 6 carbon atoms? It's hex, right? It's hex. So I know that the first name of this compound is hex. First name is hex, so I'm just going to say HEX there. Okay, HEX. Actually, I'm going to write it a bit further back, just so I have space. There's my HEX. Okay, then I have a dash here and I have a dash here. Why do I have a dash there? Because I need a number to identify exactly where my double bond is that formed my functional group, where exactly that is. How do I establish where exactly that is? Well, I number from left to right and from right to left, or from one end of the chain to the other end of the chain, and from this end of the chain to that end of the chain. And the smallest number that is closest to my double bond is going to be the number that I put in there. Okay, so let's do that. Let's number my carbon atoms from the left-hand side. That's 1, that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6, right? And now let's number from the right side. Okay, so that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. Okay, now where's my double bond? Here's my double bond. Which number closest to my double bond is the smallest? Which number closest to my double bond is the smallest? Well, it is this one and actually that one. So both of them, 3 are surrounding my double bond, because the other numbers are 4 and 4. Okay, and 4 is bigger than 3. So I know that 3 is my smallest number. Since 3 is my smallest number, then I know that the number that's going to be here that splits my name and surname is 3. So the name of this compound is hex 3-ene. And that's it. This is your complete answer. That is the name of that compound. Okay, let's do another compound. Let's do a similar compound. I'm actually just going to erase all the red. Let's do a similar compound. I'm going to erase this as well. Okay, cool. So now what I'm going to do is I'm just going to change where the double bond is. Okay, I'm going to change where the double bond is, and I'm going to put in a single bond there. If I put in a single bond, I need another hydrogen, so that I have 4 atoms surrounding my carbon, and I'm going to put my double bond there. I'm going to put it here, but now this has 5 bonds around it. I don't need 5, I need 4. So this doesn't exist. This compound doesn't exist, so I'm going to remove you. Go away. Okay, so now we've got this new compound. How do we name this new compound? Well, to name this new compound, remember, it falls under the alkenes because it has a double bond. Here's my double bond. It falls under the alkenes. Why? Because my alkenes have a double bond. Okay, so therefore it's an alkene. Since it's an alkene, the surname is -ene, right? It has how many carbon atoms? It has 6 carbon atoms. We just established this right now. So it has 6 carbon atoms. 1, 2, 3, 4, 5, 6. Since it has 6 carbon atoms, we know that the first part of the name is hex. How do we know that the first part of the name is hex? Because we can see that 6 here corresponds to hex. Okay, then I know that the first part of the name is hex, so I'm going to come back down here, and then I'm going to say this is hex. First part is hex, second part is -ene, split by which number? Which number splits this? Well, we just number our chain. Okay, so we say 1, 2, 3, 4, 5, 6, and we say 1, 2, 3, 4, 5, 6. Okay, and the smallest number surrounding my double bond is the number that I'm going to use. So here is my double bond. Which is the smallest number that is surrounding that? The smallest number is 2, right? So then this is going to be hex 2-ene. Easy. That is your answer. Solved. Okay, let's do another quick example. If you've got let's say you've got C, and then you've got C, then you've got C, then you've got 1, 2, 3, then you've got C here, and then let's say you've got that. All the carbons, all the C's must be surrounded by 4 lines. Remember that. Okay, that's why it's so easy for me to come up with these examples, because all the C's must be surrounded with 4 lines, 4 bonds. Now, how do we name this? Easy. We know how to name this. Okay, we just say, firstly, what is the functional group What is the functional group? Well, the functional group is given to me by my bond, right? Here's my bond there. That's a triple bond. If it's a triple bond, then the functional group is the alkynes. Okay, the alkynes are my functional group because alkynes have a triple bond, right? So I know that the last part of this name is going to be YNE. Okay, since the last part is YNE, I know that I'm going to have a number there. So I'm going to separate the number with dashes or with hyphens. What is the first part? The first part is given to me by the number of carbon atoms. How many carbon atoms do I have? Got 1, 2, 3, 4 carbon atoms. Since I've got 4 carbon atoms, I go to my table and I look for 4. Here's my table up here. Then there's my 4 there. My 4 corresponds to my bute, right? It corresponds to my bute. So I'm going to go back down there and I'm going to say the first part is bute because it has 4 carbon atoms. Okay, now where is that triple bond? On which carbon atom is that triple bond? Remember, you label your chain from left to right and right to left. So I'm going to say 1, 2, 3, 4. You number your chain from both directions. 1, 2, 3, 4. And you look at where your triple bond is. Here's your triple bond. You look at all the numbers that are surrounding your triple bond. Here are the numbers that are surrounding your triple bond. You take the smallest number. The smallest number is 1. Therefore, that's going to be 1 there. And the name of this compound is but1-ine. Easy. Okay, let's do another example. If you've got a compound that looks like this, you've got here's a compound here. It's just a longer chain. Remember, all the C's must be surrounded by 4 lines. All the C's, right? And then this is H, 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 this is H. All of them are H's. Okay, you've got something like that. Then, first thing, how do you name this compound? Well, first thing, doesn't matter if the chain is long. Chain looks long, doesn't matter. Use the same rules, right? First thing that you do is you identify the functional group. What is the functional group? The functional group is given to you by the triple bond here. You see that we've got a triple bond. Since this has a triple bond, we know that for triple bonds, our functional group is the alkynes. Okay, the alkynes are a functional group, our functional group, because we have a triple bond. Since we've got a triple bond and we know that these are alkynes, the last part of the name, or what I call the surname of this compound, is going to be YNE, ine, right? I know that the last part of the name is going to be YNE, so I'm going to write it down there. So this is going to be dash YNE. Okay, what is the first part of the name? The first part of the name is given to us by the number of carbon atoms. How many carbon atoms do we have here? We've got 1, 2, 3, 4, 5, 6, 7. We've got 7 carbon atoms. If we go back to our table, the table that you should memorize, you should know off by heart, we go back to that there. There's my 7 because I've got 7 carbon atoms. 7 is related to hept, to the word hept. So the first part of the name is going to be hept, right? 7 for hept. So I'm going to come here and then I'm going to say HEPT because hept is the first part of that name. And then what am I going to do? I need to specify where exactly that triple bond is. The triple bond is on which carbon? Well, you number from left to right and from right to left. So you're going to say 1, 2, you number your carbon atoms, right? 3, 4, 5, 6, 7. And from left to right, and from right to left. 1, 2, 3, 4, 5, 6, 7. Okay, now you look at where exactly your triple bond is. There's your triple bond. You look at the numbers surrounding that triple bond. Here are the numbers surrounding the triple bond. You've got 5, 6, 2, and 3. And from the numbers that are surrounding the triple bond, you take the smallest. What is the smallest number? The smallest number is 2. Therefore, you've got 2. And the name of this compound is hept2-ine. And that is your answer. You'll get your full marks. Just like that. Okay. Now, what if this triple bond was somewhere else? Let's remove this triple bond and put it somewhere else. and then rename this compound. Okay, now let us do that quickly. We've got that, so here I'm gonna give you H, I'm gonna give you H, then I'm gonna come here, I'm gonna put in 2 bonds, so therefore I've got to remove that. I'm gonna remove you, and you go away. So all the carbon atoms must have 4 bonds around them. All of them must have 4 bonds around them. Okay, now how do we name this? We follow the exact same procedure that we just followed. Firstly, what is the last part of this? What is the functional group? The functional group is alkynes, because you've got a triple bond. So the functional group is alkynes. I'm going to keep repeating myself. There's my alkynes because it's a triple bond. And since it's a triple bond, I know that the last part of the name is going to be YNE or ine. So I'm going to go back down there, and then I'm going to say dash ine, dash YNE. And then the first part is dictated or determined by the number of carbon atoms. So I have 1, 2, 3, 4, 5, 6, 7 carbon atoms, right? I've got 7 carbon atoms. Since I've got 7 carbon atoms, I know that the first part of the name is going to be related to the 7 carbon atoms, which is hept, because hept is in line with 7 there, and we've got 7 carbon atoms. So if I go back down there, I'm going to write hept. Okay, I'm going to come down here and I'm going to say HEPT, right, dash. And then which number comes between the hyphens? Well, I number from left to right and right to left. There's 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, right? Where is my triple bond? Here's my triple bond, okay? And what are the numbers surrounding my triple bond? The numbers surrounding my triple bond are 3, 4, 4, what is this now? And 5, okay. So I numbered it correctly. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Yeah, okay, so I've got 2 4s, a 3, and a 5. Then you look at the smallest number. What is the smallest number? Well, the smallest number is 3. Okay, so therefore the number that's going to come here is 3, and therefore your answer here is hept 3-ine. Okay, and then this is your answer. You are going to get your 4 marks if you do it like that. Okay, so I could come up with a lot of different combinations, a lot of different organic compounds, and we will name them the exact same way. Okay, and so far we've just been naming our aliphatic compounds, which are our alkanes, alkenes, and our alkynes. Okay, we will name more functional groups in the next coming videos. There are a lot of functional groups. I will dedicate probably a video to each functional group, giving you lots of examples, lots of demonstrations, and putting a few important points forward for you to remember, and clarifying a couple of important concepts. Okay, but basically in this video, this is essentially what you need to know for your aliphatic compounds, how to name them, and how to go about differentiating between what structural isomers are. Remember, structural isomers look different in structure but look the same in molecular formula. Okay, so now we know what a functional group is. We know what a structural isomer is. We know how to name different structural isomers, and we know how to identify different functional groups, and we know how to use them. Okay, so this is a good place to stop for this video. What's important and what I'd really like you to remember, please study this table, learn this label, study it. These rules are very important. Study this table and know it off by heart. Okay, this table is going to help you a lot. Understand it, study it, remember it. As a matter of fact, I would suggest that if you write a test or an exam, draw this table at the back of your sheet or on an empty page somewhere, so that you can actually refer to it and use it. Okay, use it to come up with your compounds, the names of your compounds. Okay, I will stop here, and we will continue with more functional groups in the next coming videos. Till next time. Number one.